Okay, so we're starting to get used to these SUVAT problems now. So this one you're going to read through by yourself first, and then see if you can go ahead of the explanation, and then just double check when you've finished. Right, so in this question I'm told that I've got a ball and it's projected vertically upwards. Now as soon as I know it's projected vertically upwards, I'm immediately going to start thinking that gravity is involved. So on my diagram I'm going to draw gravity acting down, G equals 9.8 meters per second squared. That's definitely going to be involved here. Okay, now it's projected from a point X, which is 7 meters above the ground. So we ought to draw on our ground level and then our 7 meter level as well. So marking that dimension on as 7 meters. Right, I'm going to change colour for the motion of my particle then. So I'm going upwards with an initial velocity of 21 meters per second. So my particle is going to go up until it decelerates sufficiently due to gravity that it's going to fall back down to the ground again. So that black dotted line there is going to be the motion of the particle. Right, we're asked to find the greatest height above the ground and the time of flight of the ball. Before I can do that data, my one final thing to add on is my positive direction, and I'm going to choose that to be upwards. So, filling in the data table, as of yet I know nothing about the displacement. I know that my initial velocity is going to be 21 meters per second. I know that my final velocity at the top is going to be 0 meters per second, and I'm also very aware that it's not going to be 0 meters per second at the bottom, because we're thinking about the speed at which it hits the bottom, not what it slows down to once it's hit the bottom. I know that my acceleration is 9.8 and it's going opposite to my positive, so it's going to be minus 9.8 meters per second squared. Okay, and I know nothing about my time. Back on part A then, we're looking for the greatest height reached above the ground, and as we're looking for that greatest height, that's going to be where our final velocity is 0 meters per second. Anytime where it asks for your greatest height, that's going to be where the velocity is 0. So I know V, and I've got U and A, and I'm looking for S, so I'm going to be using V squared equals U squared plus 2AS. So 0 squared equals 21 squared plus 2 lots of minus 9.8 times the height which we are trying to calculate. So rearranging that, we are going to end up with 21 squared divided by 2 lots of 9.8, which is going to give us 22.5 meters. And I'm underlining my answer. On to part B. We're now looking for the time of flight of the ball, and what we want to consider here is the total displacement that the particle has gone under from its starting point to when it hits the ground. So although it started at this point just here, it finished there. So when we're looking at the displacement, not the distance, we want to be thinking what's the movement from where it started to where it finished, and that displacement is down, so therefore my displacement is going to be minus 7 meters. So I know S this time, I know U and I know A, and I'm asked to find T. So we're going to be using S equals UT plus a half AT squared. So minus 7 equals 21T plus a half lots of minus 9.8 times T squared. Again, I'm looking for that T squared term. That's going to tell me I've got to solve a quadratic equation. So the first thing I'm going to do is rearrange, getting all my terms onto one side and setting them equal to 0. And from there I can either choose to factorise or to use the quadratic formula. So that's going to give me 4.9 T squared minus 21T minus 7, and that's equal to 0. Probably our easiest option here is to use the quadratic formula. So we've got our A value of 4.9, B minus 21 and C minus 7. So subbing that into the quadratic formula, which is t equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now at A level you will be expected to remember that formula by heart, so let's start learning it now if you haven't already. Subbing in the values then, we will then be able to calculate the value of t. So our positive value, our positive root comes out to be 4.60 seconds. And if we're careful with how we use our calculator, we can then quickly change from the positive to the negative, and that's going to give us a time of minus 0.311 seconds. Looking at that, we know that we can immediately discount anything which is a negative time, but thinking about it, that time has come from assuming that the particle was released from the ground level rather than where it was at point x. So we know we can definitely ignore that one, so we can put a nice line through it, but it's good to show that you have considered that root, and therefore our total time, the time of flight of the ball, is 4.60 seconds.